Okay, I see that we are now live streaming on Facebook as well as Zoom. So let me begin introductions. My name is Daryl Boness. I am the editor of Marine Mammal Science, and I'd like to welcome everyone to the May Editors Select Seminar. It's a series that is based on papers published in Marine Mammal Science and is presented each month on the third Thursday of the month. Although having said that, I'll let everyone know who's here that after this seminar, we will be pausing seminars until after the biennial conference. Just a couple of housekeeping details. The seminar is being recorded, and that will be available on the Society for Marine Mammalogy's website within a couple of days of the seminar. If you have questions you'd like to ask of our speakers, you can put those questions in the Q&A. If you put them in the chat, we might miss them, though we will double check and for anyone who does slip up and put questions in the chat. So with that, let me introduce our speakers today. We actually are fortunate to have two speakers. We have Drs Divna Djokic and Dr. Isabel Gonçalves. Dr. Djokic is originally from Serbia, but did a master's degree in Barcelona, Catalonia with Dr. Michael Andres, in which she focused on sperm whale acoustic ecology. She subsequently completed a PhD with Dr. Renata Souza Lima at the State University of Santa Cruz in Brazil, and she focused her PhD work on humpback whale acoustics. Dr. Gonçalves is originally from Portugal, but went to Brazil to complete a PhD also with Dr. Souza Lima, and Dr. Gonçalves has done her PhD focusing on the ecology and conservation of humpback whales. Isabel is currently working on the Whales from Hill project, which involves research and conservation efforts on humpback whales in Bahia, Brazil. So the speakers will be trading off at some point during the presentation, so you'll hear from both of them. Their presentation will be about humpback whale song. Humpback whale song is a topic for which most marine mammal scientists have at least some knowledge, including scientists like me who worked on pinnipeds my entire career. It's changes in song throughout the year may either be subtle or sudden and intense, and those that are subtle are considered changes that are evolution, and those that are sudden and intense are considered revolutions. And we're going to hear in the presentation today some information that might suggest to us why song revolutions might only occur in the southern hemisphere populations of humpbacks, but not in the northern hemisphere. The paper is published in the April issue of the journal. It should be available for a couple of weeks for all to read, whether you're a member and have a subscription or not. With that, I'll turn it over to, I believe, Divna is going to begin the presentation. Thank you very much and enjoy.
Hello, everyone. I will start.
It's Isabel who is starting.
Yeah, I'm starting. So, hi, everyone. Good morning, good evening, good afternoon, depending where you are watching us. And first, we want to thank the Society for Marine Mammalogy for the invitation and also the opportunity to give this talk about this note that was published. Was already introduced. And the note was entitled Abrupt Change in Humpback Whale Song from Brazil Suggests Cultural Revolutions May Occur in the South Atlantic. So Divna will be passing for me, please. and we will start our talk, our presentation. So, unfortunately, we have no sound, but as you can see in the spectrogram, song is a sequence of long, repetitive, and predictable patterns. Yes, you can see. Unfortunately, I don't have sound, but then we can share with you also some examples. So, Divna, please pass. And the song is only produced by males, by humpback whales males, and mainly in the breeding grounds. So, Divna, can you show some pictures? No. Okay. So, yes. The song mainly occur in the breeding grounds, but it is also recorded in migratory corridors and also in feeding grounds. So some recent studies, as you can see, Divna, please pass. Some recent studies show song opportunities of sharing, and also in feeding areas in Antarctica. So we know that the song is happening mainly in the breeding grounds, but also there's some opportunities of sharing the song in Antarctica, in southern hemisphere. So, please, Divna. So what is the song? The song is structured by units, a phrase, and themes. So the unit, as you can see in that selection box down, is the simplest component. Thank you, Divna. And a sequence of units compose a phrase. So we can compare, comparing with our sentence. As humans, we have the words. So for whales are the units, and a sequence of units, in our case words, form a sentence, a phrase. So the repetition of that phrase that you can see in the yellow box, the repetition of that phrase constitute a theme, and the repetition and the sequence of different themes is the song. So each breeding population has its own type of song in each breeding season. So the song works as a vocal identifier for each population, and is culture transmitted. How? Males learn from each other listening. So in that way, we see that we have the cultural transmissions of song that we can see in the humpback whales populations. So next, please. So how could songs change? So as I told you, we have the units. So the units individually, or the set of units, can be excluded, included, modified, rearranged, and that can lead to introduction or the exclusion of entire phrase, and in consequence of the theme. So we can see different degrees degrees of changing, with types and different types and rates of changing. So in this talk, we're gonna focus distinguish in two terms. Please, next, Divna. In evolutions and revolutions. So what we want to say with that. Next, please. So song evolutions is moderate and progressive change that happen constantly, and some revolutions is the abrupt change with a pinpoint source population. So as was first described by Noah and collaborators in 2000 for the Eastern Australia population. So the first record of cultural revolution for humpback whales was in that case. Okay, so next, please. Now, Divna, we'll start. Thank you.
Hello, everybody. Thanks for coming. I'm Divna. So let's let's continue where Isabel stopped. As you guessed from the title, our study site was the population of Brazil, or breeding stock A. It's the Atlantic coast of Brazil. We had two sampling points, both in the state of Bahia, so relatively close to each other. And the sampling dates were in the years 2017 and 2018. However, I would just like to mention that this study was a part of a bigger study that involved my PhD thesis. So we are presenting just a small piece of it, okay? So you already saw this slide before with Isabel. I just wanted to remind you that for this research, we were focusing our methodology on the unit, as we believe the unit is the most simplest and least biased element of the song to determine. Of course, when you see this, looks very clear and obvious, but as there's always but when you delve more into the matter, you start to find little caveats to determine what the theme really is, phrase, and so on. So that's why we were focused on units, as we believed it's the clearest element to describe or to define, at least. Okay. So this is how it started. We would take the recording, feed it in Raven. Raven would give us a spectrogram. This is what you see. It's called a spectrogram. It's a visualization of the sounds. It gives us frequency in time. And then you can see nicely how these units are separated, and every unit was given a name based on its type. So that was another caveat to work on a methodology how to determine each unit type. Of course, this methodology already exists. We just tried a bit to update it, let's call it like that, which was in part a matter of my PhD work. So as I said, here it looks all nice and clear. It's not always like that, but here you can definitely see how, let's say, unit 14 is different from the unit 6, and so on, okay? So once all the units were determined by type, they were boxed nicely in Raven. They were determined by type, giving a name, or in this particular case, number. And we use it for further analysis. Firstly, what we did is we would build a dictionary for every year. So we would take a representative of each unit type. We would take a visual representation, spectrogram, and also a sound sample. We would make a dictionary of all the units that were used in a specific year, okay? So all the unit types that whales in a particular year used to assemble their song, okay? So strikingly, you can see how songs differ from 2017 to 2018, okay? Even just by a mere glance, you can see just by number of unit types that were used, how much these two songs differ. I saw many population songs in different years. I've never seen such a strong, intense change from one year to the next in the reduction of units, the number of units used. So please, if anybody out there listening and know a bit more about this, I would love to hear if you know any example of this very intense reduction in the units used. So consequently, the number of units used reflected on the complexity of the song. But just as I forgot to mention that out of all these different unit types used in both years, we actually found one unit type we called number 3 that was actually used to combine both songs. So 17, and it reappeared in 2018, but in a totally different context, which we know the whales actually do. They recycle the same unit types to compose totally different phrases and further up. Finally, the results show there were 20 unit types used in the song for 2017, and this number got reduced to only 8 unit types in the consequent year. So what we did next to make it more solid, the data more quantitative, we would use the Levenshtein distance, which is a very common method used in humpback whale acoustics. Anybody involved or ever read, most probably after the year 2010 would come across this methodology. We did a small twist with it. I'll explain about it in a second. So the idea was to take the recordings as they come, so raw strings as the whales sing it, and translate it directly into unit types. So each unit, as the whales sing it, we would translate it by type, as you can see in the lower area, how it goes one by one. So you had the whales sang unit 1, 2, 1, 19, 17, and so on. So we would simply just transcribe what we saw on the screen. And as I said, we use the raw strings. This is the twist I mentioned earlier. Usually scientists in this area use representative strings or median strings. So the most common sequence of units, or the one that is similar to other recordings in the area, we just use as they come. Okay, so how the whales sing it, we wrote it down. This is the twist I mentioned about you before. I'll try to go real quick through this. It's a bit scientific, but I'll try to make it as simple as possible. I just couldn't resist it because I love it so much. So with the Levenshtein distance is actually a pretty simple method, even though it sounds intense, it's not. It's just a method that was actually developed, as Isabel nicely said before, language. So there are similarities. It was invented to compare two words and to tell how different they are. We'll just measure the string of letters as a word is, a string of letters, and compare how much one word is different from the other. We would do the same, just instead of the words, we would use the sequence of units, okay? So you can think of units as letters and the sequence as a word. How it does, it takes 3 calculations. So insertion, deletion, and substitution. Let's see how that actually looks like in real life. So let's say word whale towards tail, how different it is. Initially, you can say the word tail is one letter shorter than whale. So there's 0 insertion. Subsequently, 1 deletion. You can see the calculation on the left part of the screen. And then finally, if you end up with the word hail, to turn it into tail, H would turn into T. So there was 1 substitution. Altogether, Levenshtein distance between the word whale and tail would be 2, value 2. Simple as it is. However, we had to do a small twist because of the different lengths of the strings we used. We had to normalize it just by a slightly different version of the calculation, which now is called Levenshtein similarity, so index. So it says actually how similar the strings are, okay? And this is what we get. We would compare every recording to every other recording in the shape of the string. Calculate Levenshtein, get a value for each of the pairs from both years, so 17 and 18. Everything compared to everything. We would get values, make a graph, and this is what we get, okay? So on this side, you can see the names of, or actually both sides, the names of the recordings, okay? And this is the value of similarity. So 1 is 100% similar. We confirm this here. So this recording of the year 17,000 compared to itself gave 100% similarity, of course, okay? So I hope you understand how it works. This square is all the 17 recordings compared to itself, and you can easily see how they compare between themselves and how there's a certain level of similarity between the recordings. The same goes for the year 18. So all the recordings from the same year compared to themselves show a certain level of similarity. And the interesting part are these empty spaces, which are actually showing how 17 is compared to the 18th recordings. Okay, so for example, this recording, this square represents similarity between this recording from the 17 and this recording from the 18, okay? So the similarity is 0. And this is what happened throughout the season. So you can once more see how song change intensively from one year to the next, which is the base of the thing we called song revolution. But why we cannot call it directly that, Isabel will discuss with you later. Okay, sorry. So we can say that very possible it is revolution. However, there are caveats that restrain us from confirming this. This is hot data for my thesis. It's not published yet. I just wanted to show you that as I worked on this data for 4 years, Brazil, you can see that even in this bigger context of 4 years recording, you can see this big gap in similarity between the year 17 and 18, okay? So in a bigger context, it is still obvious that the song intensively changed. And then finally, just for your visualization, we haven't really made any calculations based on the song. We haven't quantified it in this way, but it's a nice way to see these are actually really the songs from the 17 and 18 in the colors. Different colors, you can see different themes. The songs are made of. So you can even see in this way how songs change. So 17 had several different themes, some of them repeated. It's organized differently, while the song 18 only had 3 different themes, which were not repeated in a session of a single song. Again, for my colleagues from the area, just a quick snip of a methodology. This is how we tell what the song is. For this methodology, this is again a question that is still under development, the methodology and different approaches, how you determine a song, because it's not always as clear. And this is what we use. This is a very nice paper. It's Malia et al. And it actually gives you a way to tell out of a really wrong recording where the song actually starts and ends. It gives you straightforward info. From there you can work on the songs and actually themes within it as well. So very not biased way. I would encourage researchers to try and use it. So this I'm giving it back to Isabel to discuss with you where this come from and what can we learn from this intensive change of songs. Thank you.
So as Divna told you, we have a potential revolution in our data. So to understand if it's really the revolution, as I told you in the beginning of our talk, we need to understand the source of that why the source of the abrupt change in the song. So a lot of studies in the literature discussed how the humpback whales could have acoustic contact. So we know that the breeding stocks, the different populations can have acoustic contacts visiting another breeding ground within the same breeding season or in different years. And we know that individuals from different populations could have acoustic contact also in migratory corridors and also in feeding grounds. So as the work of Darwin and Souza Lima show us some song similarities between the breeding stock A, the whales that come to breed in Brazil, and the breeding stock B, the whales that migrate to the west coast of Africa. So they already show some similarities between the populations. So we had some evidence of acoustic communication between these two breeding populations, okay? So what other examples we have also in the literature nowadays? So a very important work for us, a paper published last year, presents that a whale sighted in November of 2017 in South Africa was reciting in Brazil in the next year. So in the year that we have the abrupt change. But unfortunately, we don't have data evidence to understand if that whale was a male, but is evidence that the whales are migrating between the different breeding grounds. And other examples exist, as you can see. Next, please, Divna. Has, for example, a whale that was sighted in Brazil some years ago was reciting in Madagascar. And also, next, please. Some whales first sighted in Equator, some years after were recited in Brazilian coast, on the Brazilian coast. So it's very common that we nowadays we see that recitings of different whales migrating, traveling long distance between the different breeding areas, but not just in breeding areas. Next, please. A recent study published by Marconi and collaborators showed that some whales from the breeding stock A, so the whales that migrate to Brazil, can share feeding grounds with the breeding stock G, so the whales that use the west coast of the South America. So we have some examples of the movement of the whales around the southern hemisphere between different breeding grounds and also sharing the feeding areas. So next, please. And what's happening in North Hemisphere? We have studies published that show evidence of exchange of song between the different populations, but until now, no revolutions have been published in the populations that we know in North Hemisphere. So why is that happening? In the Southern Hemisphere, we have some cases of abrupt change and also cultural revolutions. So the hypothesis of some researchers is that has in the Southern Hemisphere, we have the lack of physical barriers that we have in Northern Hemisphere with the land masses. So that lack of physical barriers in the feeding area in Antarctica, in South Hemisphere, allow a greater connectivity between the breeding stocks in the Southern Hemisphere. And that greater connectivity can allow also some change, some exchange between the populations and also the occurrence of cultural revolutions. So next, please. Until now, we have we have a lot of examples of cultural evolutions in song of the populations in Southern Hemisphere of the Pacific, and we have a potential one here in Brazil. So maybe the lack of physical barriers, the different characteristics of the Southern Hemisphere can lead to different strategies, different cumulative cultural strategies between the populations, between the North and the South. So that effect, next please, is strengthening the hypothesis of the Southern Hemisphere cultural exchange. So here in South Hemisphere, we have a greater connectivity and a possible a cultural exchange between the different populations. So also a very interesting fact is that a recent publication of 2 years ago show also that the song exchange, the direction of song exchange between the breeding populations from Pacific were happening in the direction from Australia to Equator, so west to east, but that revolutions, that exchange of the songs in Pacific populations in 2018 18 was not observed in our song here in Brazil. So maybe now we have to investigate it to see what could happen in the next year. Who knows that song exchange can arrive also, could also arrive in Brazil. So next, please. Next, Divna. Thank you. So what are the next steps for the future studies in this area? So one of the questions is when different is different enough. For example, in our case, as Divna told you, we have a similar unit between the song of the 2 years, but that unit was in different contexts, and we have a different structure in comparing the 2 years. So, but if we have 3 units similar between the songs of different years, we need to understand how what difference is different enough. So 1, 2, or the context. So it's a very important thing that we should discuss. And also here in the study, and there was a focus of the PhD project of Divna, her work, is using the unit as a basic level of comparison. But usually in this type of studies, researchers use the phrase. So it should be very important to compare the different methodologies to see how that could influence our results. And for sure, that long-term acoustic monitoring and comparison of songs between the different populations should be done to understand the dynamics of acoustic interaction and the process of song evolution and revolution. So in our case, we should now compare our data to the song of other populations to try to understand the source. If we have a source of the novelty of our song, to see if we can really call for a cultural revolution. So next, please. So we are here present this work, these results. Also thanks to all co-authors. So Dr. Renata Souza Lima is also here to then answer the questions and talk with us about all the work. Next. And we thank also for the financial support from the different institutions that allow to making our work. And also we are grateful for the help of a lot of people that help in the analysis, the data collection, also reviewing our work, our text, and also the institutions of the other authors that are not present here right now. And also thank you for your attention, for the opportunity. And we are here now to answer any questions and talk about the song also with Renata. If Renata could appear, open the camera so everybody see her. And thank you so much for the attention. Thank you, Divna. Thank you for all the partnership in this work.
Well, thank you, Isabel and Divna, for an exciting presentation, a very complex presentation that taxes my ability to follow it completely, but I find it very interesting work that you guys are doing. I don't know if we have any questions yet in chat. I'm just gonna look. At this point, it does not look like we have any questions from the audience. So let me kind of start out with maybe something more basic understanding. So in a given year, will there be more than one song, or is it always the same song for a given population?
Divna, want to answer? Or
Yes, sure. So yes, songs get changed over time, but we like to say, because it's easier to work on, that every season has a single song. So as you saw, that song actually evolved through the season. So they changed from the beginning to the end of the breeding season. And now we actually know that this change even happens on while migrating or feeding ground. So it's constantly changing a bit. But let's say the base is always the same. I mean, not always, but for a particular season, all the whales are supposed to sing the same song. And that's why you can actually have it's a consensus. Let's say that you can actually have only few males recorded to tell this is a song from a specific season, from a specific population, okay?
Thank you. I see we do have maybe some questions.
There is. Thank you, Daryl. So there's a question here: were you able to source any data from before 2017, 2016 to see the speed of change?
I think that also Divna can answer, because in their PhD, she analyzed a bigger data. Divna?
Yes, so we had data even from before what I did for my thesis. My thesis involved data from the 16th until 19th, but there are plenty of recordings even from Renata's PhD. So you can actually see how songs evolve. I can tell you for this particular time slot, that you can see how song evolves. So it changes from one season to the next a bit, and then comes this 18th season, and it's totally different. I remember the first time I opened the recordings, I couldn't believe it, because I knew the song by heart from the 2 years before, and I knew the units, and I would notice, this is a slightly different. But and then I saw the 18 that I couldn't believe. I was checking like several times, this is really Brazil, because I had a huge data set. Is this really Brazil? Is this really 18? It was really a shock to see. That was a spark. Like, we need to publish this note because everybody should know about this, because so far we only knew these intense changes were happening around Australia. And it turned out there's a big chance they do happen in Brazil because of this recording. We had a lot to catch. So it's definitely a specificity of the year.
One more data question was, sorry if I missed this, but how many samples did you have for 2017 and 2018?
Okay, so 17 was not the best sampling year, definitely. We had 5 days of recordings, I think, altogether that used in the research. And yes, there was a lot of unfortunate events, let's say it. The 18th was much better. We had from 2 sites, we had the manual hydrophone recorded and the automatic recorder. Isabel knows more about it. She's the moderator of the recorders from Serra Grande. But the 18th was much more solid data set than 17. However, as the 18th was the change song, it gave us the enthusiasm to say that actually we can talk about this change more confident, as we had a lot of data to confirm it. Isabel, please tell a bit more.
Yes, and a very interesting thing is that our data from 2017 is from the end of the season. So we have that specific data in the end of the season, and then in the beginning of the season of the next year, when we have more data, we use, I think, from here from Serra Grande, we use 3 or 4 days of recordings. But if the change happened between the end of the season and to the beginning of our data is from the end of one season and from the beginning of the other, that change happened probably not in the Brazil ground. So it happens far away from Brazil. So probably in the feeding area. So it's a very interesting fact in this note also. And yes, here from Brazil, we have here from Serra Grande, we have in the second year a little bit more recordings from autonomous recorders from 2 months, so 2-3 months, and but it's very interesting that here we see that big step, big change that probably is happening far away from the Brazilian coast.
Perfect. There's more questions here, and a comment from James Hadnall saying, as the individual who first located a singing humpback underwater and identified that one as a male back in 1977, he says, I greatly appreciated this presentation. So thank you, girls. And there's a question saying, have you made discriminations and comparisons of the units graphically by spectrograms? Can you tell which connotations have you used?
Sure, I I didn't want to go more into details. I wanted to encourage everybody listening to go into the work and use the chance while it's still open for downloading, and to go into more details on methodology. Also, you have my email there, or Isabel, so you can text or email us if you have any more questions. Just to answer quickly, we used several measurements, 11 measurements taken from the spectrograms in Raven to do the comparison between the units, actually to determine their types and further to compare between the types. So it's all very well quantified, and afterwards we used random forest to quantify the comparison. So it's generally how it is done. So it's a common methodology.
All right, I've got another comment and question. We also had a lot of problems with 2017 data, bad year for song in the Southern Atlantic. I also wanted to ask if you saw more change between 2016 and 2017 than normal, rather than a very slow rate of change. I ask because the rate of change in a revolution is about 2 seasons per year in previous studies.
Okay, I would really like to know where these information are coming from. Well, I would really love to know that. So 16 to 17 was a very moderate change for us. I was actually working on the data from Brazil and from the breeding stock G for my thesis, comparing the two. And for the other coast, for Pacific coast, it was the same. It was a very mellow evolution happening from 16 to 17. So nothing so intense.
Something building up for the year after?
Yeah, something, some glitch happened from 17 to 18. Like they left with one song and then came back with a totally different song. As I said, in 18 we had the whole season captured, so we can tell that it actually they arrived on the breeding ground with a totally different song, which is building up the hypothesis that the feeding grounds are also a very fertile ground for this song and cultural basically exchange. Well, I didn't understand this part when they say the evolution is 2 year. Can you please repeat that
part? Two seasons / years. So
okay.
The rate of change in a revolution is about 2 seasons. In previous studies,
yeah,
says the comment.
So there is a big, not big, but there is still discussions on this topic, as all the data about revolution are basically coming from a single lab and from a single spot in the world. So there's a lot to discuss and to see how other populations behave and how their song changes. For example, we know South America is the song is very variable, for example, in the sequence of themes. While North America, they're very good pupils. They always sing theme 1, theme 2, theme 3, most of the cases. And in the Southern Hemisphere, they're much more random in displaying the themes while compiling the song. So this is just an example how different populations obviously have different ways of producing their songs, and this could be one of the ways. The first paper that noticed the revolution happening was Dr. Noah and the colleagues in 2000, and they had this huge data set that was capturing basically the whole season with thousands of hours of song, and they were able to actually catch the whales that brought the new song. So that was an amazing thing. And even in that paper, they say that it took 3 years for the population to entirely grasp this new song, to adapt it. We don't have such a data set and hardware to work on, so we don't know how. Well, actually, I do know, to be honest, because I have 2019 data in my data set, that if the song 18 stayed, it didn't. But we don't know if all the whales were able to grasp a song. But we would say yes. As I said, we had autonomous recorders, so we had plenty of hours we went through, and it was always the same simple song showing up.
Very interesting. Then
Yeah.
there's one more comment and question. Good morning from Brazil, someone says. Congrats on the presentation. Question, do you believe that the contact that the stock A from Brazil with the other different stocks from the feeding ground has some influence in the song evolution or revolution?
Isabel, you want to comment on
I
that?
can ask. Okay, I can comment. So thank you. So as we told you, to be sure for the revolution, we had to know the source. So it's because of that we call abrupt change, because in the literature nowadays, a cultural revolution is when we know the source of the change. So until now, we didn't find it, but we need to compare with more data from all the southern hemisphere. But we believe that could happen through acoustic contact with other populations. But to be sure of that, we needed to have the data of other populations to compare and to see the similarity. So now the next step is to do it, to try to find it, and to have to be sure of that. But with all the evidence of that sharing feeding grounds with other populations, and also the work from Darwin and Souza Lima showing the similarities between the breeding stock A with the breeding stock B, we believe that it could influence in the abrupt change for 2018. But the next step is to try to find that source and to be sure.
Just a really small comment. The Schall paper from 22, it's actually showing this beautifully, how the Elena Schall, the main author, first author, she took the recordings from Antarctica and then managed to compare, to find sources for each song in different areas. So Brazil and breeding stock B and C from Africa. So anybody interested in this topic, make sure to check this paper, Schall et al. 22, for more detail. That's one also very, very interesting paper that promotes the idea of a feeding ground as a mingling point for cultural exchange.
Perfect. We have someone keen to collaborate with you guys. Where should they contact you? There's someone saying, I have data from Eastern South America. I'll be happy to collaborate. So would you like to be contacted? And can you share your email address again?
Yes, for sure. We can share our emails here on the chat. I don't know if in the chat could be, or in the end. Yes, the end of this. Okay, perfect. Thank you, Divna.
Perfect, because you were already saying to me there's a lot of collaboration happening in your project. How did you come to work on it yourselves?
May I jump in?
So
To
I have another quick question. I mean, I find this fascinating and makes me wonder how these changes actually come to be. That is, if I'm a male whale and I go from the breeding grounds to a feeding area and I'm exposed to a bunch of other whales from other breeding areas, and I hear maybe 3 or 4 or 5 different songs, although I guess you don't hear that songs except at the breeding ground. So how do they get these new units, phrases, or songs unless other males come to breeding ground and are using a different kind of a different set of units, phrases, and songs? So any ideas on that, or does it not make sense what I'm asking?
I could
Renata?
answer that.
Yes.
So hello, everyone. I'm so happy to be here, and I'm going to try to answer both. Can you see? Because I can't see myself. Okay.
Yes.
So first, thank you for the amazing questions. The first I'm going to address Daryl's question, and there's actually some evidence from the Northern Hemisphere that shows that in the winter, while they're in the summertime, while they're feeding, there is actually songs being sung, but not complete, not in that usual hierarchical structure that we describe them in the breeding grounds. So apparently there is some sort of a starting of like a melody sort of thing, and it's not complete. They're trying it out, like in a studio, they're trying out combinations and parts of combinations, and then as the feeding season progresses, and I think, if I'm not mistaken, Salvatore Sergio was involved in this research and his collaborators, it becomes more like a full song, is that what they said? So it's like partial songs and then full songs. And then what I would, suggest or imagine is that as they break up, not that much in the Northern Hemisphere, but here in the Southern Hemisphere, where they all meet and they can get contaminated by the new song, that it's contagious. They like novelty. For some reason, novelty is selected for, and it becomes more common. So they end up converging to a song. And there's no evidence for that for sure. But as they come up, I imagine that as they come up from the south, from the north, we know that there are pieces and bits that are put together, but they're not really, we don't know if they're really sharing. There's no evidence. But here in the Southern Hemisphere, they might be sharing, listening, and trying things out in the Southern Hemisphere, like Shao et al. Showed. And then as they migrate up, that novel hit catches up, right? It catches up, and then it arrives on the breeding grounds, and then it arrives a little bit different everywhere. And that's why we can tell where that singing male comes from, if we know the song from all the populations, because they all converge into a single song. It's amazing. It's something that, I mean, who doesn't get a song stuck in their head, right? They do too, I guess. Their humpback whales are just as musical and as cultural as we are. I don't know if I answered the question, but I tried to.
Yeah, well, I think the question was difficult to answer, especially in the absence of more information. But yeah, it is interesting, I think, when you put it in terms of humans getting a tune in their head. So yeah, thank you very much.
Wasn't there a question before I had
Yeah. Do we have more
Hannah actually tried to answer? Something about the...
I think we answered all the questions that we posed to you. There was another question here about, would you say your study can give an indication on whether the humpback whales are endangered or not?
I could maybe try to answer, although I think Renata would be much more appropriate to talk because she's in the area for much longer. And as I remember, she telling me seeing the population recovering while doing her PhD in the 2000. Well, it's better if you say, but the idea is that it was so hard to find a whale to record. And I had a different problem because I would submerge a hydrophone and it was just a chaos of a lot of them singing at the same time. So I was annoyed in in this sense. But yeah, so what do you depends probably on the population, but we can actually see, I would say, it's in my personal opinion, that if songs change more drastically, probably the populations are growing. In a sense, there's many more individuals that are introducing their idiosyncrasies, their mistakes, and all the other peculiarities that are getting incorporated into the song. So my guess would be that if there's more whales basically involved in singing, the song would change faster. But how to determine what is faster, that's a that's a big question. But theoretically, this is what I would say, that song has a potential to actually be involved in the studies of population recoveries, yes.
And then there was a question if you will be attending the conference in Perth and bringing your research there. So you've already made some fans. People are interested.
So we'll try, Renata and I. We have our work submitted and accepted, but now we have to see if we have money, enough money to attend. But we're gonna try to go to present our work, also from other results from Renata's project in the north of Brazil, and also other data with abundance data here from Brazil in the area where we are working. So let's see. We hope. Fingers crossed. Let's see.
Hopefully. Another question just came in. How do the male whales decide what song to sing? Who leads the whole population to go sing the same song during the breeding season? Is it the oldest one? And what is the evidence or your opinions on that? Thank you.
Oh boy, I wish we knew. Those are all really good questions. I mean, this is in the back of our heads. Everybody that had that study humpback whale song evolution and signal evolution in general is like, how does it change? What's the mechanism and the process behind what we see in the song? So we don't have those answers yet. So let's keep looking and listening and trying to figure out with more collaboration and like more ears in the ocean so we can hear better and hear more.
What a perfect way to round that up, don't you think?
Yeah, absolutely. So we are a little past 9 o'clock, so I think we have no more questions there. We won't take any more questions. So let me just thank you, all of you, for excellent presentation. Looks to me like you have a lot more things you could and will be doing. And we hope to see some more papers in Marine Mammal Science from your work. So thank you very much, Divna and Isabel, for an excellent presentation. With that, we'll call it an end to our seminar today. Thanks.